This is vvvvTv.
Hello everyone, welcome to season 2 of vvvvTv. My name is Jorek, with me
Anton.
The two of us are part of the team who are creating vvvv for you. In this pilot episode of season 2, we wanted to talk about
reading sensors and controlling motors
with
Arduino.
Where is it?
Yeah.
Here. Okay. So it's not the hottest topic right now. If we did this episode like 15 years ago, it would have been
Super excited. Back in time.
Amazing. But so let's pretend it's like 15 years ago.
Yeah, but it's still exciting to prototype with the hardware.
I think it's still the quickest way to read data in. No?
Let's do this.
So let's have a look. First, we wanted to show people what we mean. Just an example. Operator, can we go to split screen? Yeah. So what do we have here, Otto?
So we have a vvv and a renderer. Now we have here accelerometer sensor, and we can change our 3D scene with that. So I can rotate it, and the T-port rotates.
So the values the sensor reports are directly. Can you show maybe briefly?
So these are the values from the sensor, rotation on X, Y, and Z axis, and these are controlling the T-port.
It's pretty much.
And also we are doing filtering here, so the values jitter not so much. Oh, let's do this without, like this. And you see your T-port is jittering. So this is cool, just you can filter that.
Let's see, the delay between the video and... Yeah, there is a bit of a delay of our little camera down here. So when I do this here in the studio, it's like, this is real time. There's no delay.
But we can deal with it.
Yeah. So, okay, so this is kind of setting the scene of where we want to get at, but what would be the hello world of reading sensors?
But before starting this, we have to configure our Arduino. We do this once. We just put a Firmata firmware on this only once. Then we just do it. And everything what we will do, we will patch in vvv.
So that's this core idea of, instead of writing custom Arduino code all the time, you just bake this firmware called Firmata onto the device once, and this just reads pins and can write to pins without any additional configuration needed, right?
Yeah, exactly.
That's the idea. So how do we do this?
So you need this Arduino IDE, and then you have to install it. Then you go to the library manager. You type Firmata, you see, and you just click install. So now this Firmata package is installed. Then when you did this, you can, under examples, you go to Firmata and you choose standard Firmata.
Okay. We ignore all the other options we have there?
Yeah. So we select our board. It's Arduino Uno comport 3. And we say upload. So now the firmware goes to Arduino.
Just
uploading.
Taking a while, compiling, uploading. Okay.
That's it. That's it.
Okay.
So you don't need this IDE anymore. Close it. And if you disconnect power from Arduino and connect again, then the Firmata boots up and
it's still on it.
It's still on it.
It's baked.
Yeah.
Okay. Now, what's the goal now? For the first thing, we want to read. We want to have a blinking LED. That's kind of the.
This is hello world of physical computing. What we will do is a physical computing, because we are like between digital world and physical world.
Yeah.
So, what do we need?
The Firmata package. Is that the first?
Yeah, you just open the Node browser and you type Firmata, and you see that there's a package, Firmata. You click on it, it's immediately installed, and you have your Firmata device. So let's take it. A lot of pins, but we don't
Yeah,
need...
it looks a bit complicated,
No,
scary, but
easy. So we just need we need these 2 pins. And now let's enable the device. Now it's
I would like you also to show the COM port selection in just in case.
True. Because now we have only 1 device, but it's COM port 3. So now Firmata is ready. Now I have to connect
Can we go to the split screen?
Our LED example. And you will notice that patching the real world is much longer than...
Operator, can we go to the split screen?
Than patching the...
Yeah. So some kind of physical computing fiddling around with little cables and little pins. This is the complicated part, I would say. But Anton knows his pins and breadboards and wires.
Let's leave it like this.
Yeah.
So the LED is now connected via a resistor to the ground and to the pin 9 of the
Pin
Arduino.
9, okay.
Yeah. So let's first write the...
We want to turn it on and off.
Turn it on. Okay. Then if you type in the Node browser DigitalWrite, so this is just the on-off values.
Mm-hmm.
We'll have to say that it's pin 9. I can connect it because this pin takes a sequence of pin values, so we can control several pins. But we have only 1, so let's do the spread out of this. Now. And let's try. We turn it on.
Oh.
We turn it off.
Okay, there's a big delay in the video, but that's not...
Let's see how it behaves when we try to write float values into that.
Aha, so instead of just turning it on and off, we're now sending like a...
wave. We want to take a breathe. So
a breathing LED. So we're using AnalogRead for this.
Exactly.
Okay.
And we take float version. So now you see that you can set float values. And for the pin 9, like this, then I connect this. And if operator, if we can have our LED, and now I will change the value in the patch. Yeah, you see it's like dimming and going like lighter. Let's doing this manually, it's ridiculous. So let's put an LFO.
Let's
LFO.
add a nice wave shaping animation.
Yeah. So let's make a sine wave. And now you see that the sine wave goes from -1 to 1. We have to map it from -1 to 1. And the output is from 0 to 1, right? Now let's plug it into AnalogRead.
It's breathing, Anton. I think it's alive.
So let's slow it down.
Yeah,
Okay, you get an idea.
Yeah, you get the idea.
It looks beautiful in reality.
In real life.
Yeah. All right. That was the hello world of the physical computing. As easy as this, you just enable the board, and do AnalogWrite and DigitalWrite from whatever values you calculated. It can be super complicated calculations that you send to the board.
Looks easy so far.
Yeah.
Let's take it a step further. What else do we have? What did you bring? What about this thing?
Yeah, let's
We connect this.
it's a force resistor, so the harder you press, the resistance change.
We can show it here. Huh?
Yeah.
Yeah, just a pressure sensor.
Yeah.
In German. In German, we would call
Well,
it
the
pressure sensor.
pressure, I guess the pressure is always like atmospheric pressure, and this is like the force that you apply.
Okay. So
let's do that.
show us how you connect this.
Yeah.
Can we again, operator, split or full, yeah. So Anton is doing some cabling magic there.
So how should it be? Like probably like this. Okay, so now
Back to the patch.
I will disconnect.
Yeah, let's
This
remove.
thing. No, maybe we will leave it because
Okay.
so we want to read values.
So now the other direction.
Yeah. So
Instead of sending data out, we want to read data from the device. Okay.
and what should I type in the node browser? What do you think?
I would assume it's an analog read.
Exactly. Because AnalogWrite will be just 0 and 1, and we will AnalogRead, so we will get float values. Float?
So you were just meaning digital versus analog.
Yeah.
But we saw only analog because you typed analog.
Exactly. Yeah.
Never mind.
So
So which pin is it on?
it's analog pin. It's important that it's not like digital pin. Operator, if we can see the board, then you will notice that we are on a pin, like on this side of the board, there are analog pins.
We don't see it in the video, but it's like this is
Yeah.
pin 0, if I see it correctly.
Yeah, analog pin 0, exactly.
Okay.
So by the way, if I open, like this. So we have analog pins and we have digital pins. By the way, we plug the LED on the pin 9 and it has special tilde sign, which means PWM. So this pin can send or output the PWM modulated values. So it's not 0 and 1, but everything in between.
It can do both, no?
Yeah,
Digital
exactly.
and analog. Yeah.
Exactly.
Okay.
So you see, not every pin can do this.
Yeah.
Only those with tilde. So, but we are now an analog pins, analog pin 0.
We're gonna read that.
Yeah. And now let's.
Are we here already?
Yeah.
If I press, works. It works already.
So if you're pressed, the value changed.
Yeah.
So
Rats.
this is it. It's
As
so
simple as that.
it's just placing a node.
Okay. Would we now be able to control the LED when I press the sensor?
Yeah, but why would you do this? Why you need vvv for that? You just plug values in and then.
Probably not something you would do.
No, I would, because maybe there are some neural network
In between my
In
fingers
between.
and the LED.
Yeah,
Some crazy number
calculation.
crunching going on.
Yeah, and then you send it
Yeah.
back to physical world.
Yeah, let's
Let's do this. So we have this part here. This I don't need anymore. So we want to AnalogWrite again.
back
Float.
to the LED.
Yeah, our LED. I have to.
You need to wire it again.
And this is so easy to patch, and then you have to deal with physical world again. So let's go to pin 9, and this goes to the ground, So let's see if you can see both.
The LED.
Oh,
No, leave it. This coming
Like
in,
this, yeah.
LED coming into view. Okay, but now you need to
yeah,
wire it.
we have to patch it. So
So back to the patch, please.
I guess we have to see both. So we need get this value, and you see that this node gives us a spread because we can read not only from one pin of the board, but from a list of the pins. Now we're reading from one pin, but we get also the list. So we have to take one slice of it. So the 0 slice. This is it. And now we have to connect this to the AnalogWrite that writes to Arduino pin number 9. But I can connect it. Classic, because it will be the loop. So what we will do, we will read in one frame and write in the next frame. So we need a frame delay for that, like this, and then we can connect. So what happens now? We read the values and writing them to the...
Oh, it's doing it.
Okay.
Again, massive delay on the screen, but...
And here in a patch, of course, that here, in between, from reading and writing, here's your number crunching happening. Here's a multiplayer game happening, and when when I'm winning, then LED lights up.
Sky's the limit.
Yeah.
Okay, I think we get the idea. Like, read, it's just one node that you need to place. AnalogRead and another to AnalogWrite.
Yeah.
It's that easy.
I guess it's good when we see the patch.
Once you figured out how you have to wire the things in the physical world, the vvvv part is a no-brainer.
Yeah.
What was next on our list? We wanted to show how we can control a servo.
Yeah. So we don't need any more of these things. I will disable for now, just Firmata board. We don't need this. And what do you think? What should I type now in a browser if I want to control a servo?
Try servo. See?
ServoWrite.
Told ya.
Again, I can connect because I deleted too much cons. Like this. And now let's connect it again.
How do you connect it?
Wait. I will talk about
I wouldn't know.
So the servos, yeah, nobody knows because you have to always read data sheet from all the sensors, all the servos, because the pins are differently. So this servo has a white wire for controlling the servo. So this guy should go to
the
pin number 9. Would you please?
Okay, I can try. But can I unwire all the other things here?
Yeah, please.
Okay. The yellow one in this case, to number 9.
Was it 9? It is 8.
What?
I will do this.
See? Hardware.
So ground and 5 volts.
So here is the motor down here. Can I? Here, sorry. Coming up. Yeah, perfect.
And I guess it's good when we see the patch again. So
turn it on.
Yeah. So we'll turn it on now. It takes time.
Yeah, we haven't mentioned this. Turning on the Firmata device takes quite a while.
Yeah, because it has to talk to Arduino and say, hey, hello Arduino, I'm Firmata here. So
negotiating a few things.
Yeah. And when it's done, it should.
Takes like ages.
It looks
too long.
It's too long. Let's see what happens. Maybe, wait, I disconnect the servo first. Let's try again.
COM3 is, everything is... Are we dead?
I don't know. Looks like, yeah.
Completely dead.
Completely dead.
Interesting. Well,
Oh.
let's shut it off.
No.
That's an interesting one.
So, wow. It was not like when we tested.
The 10 times we tested, this did not happen, but...
By the way, help browser, if you type here, Firmata, you have some help patches showing what we're doing now, basically.
Okay, let's try to quickly do this again.
Yeah, so Firmata, device, enable.
4, 3, 2, 1.
Boom. Why?
Interesting.
Hmm.
Should we unplug and replug the USB?
Yeah, probably.
How could we have destroyed that? So,
But it works. It says, okay, COM-port 3.
COM-port 3. No. It blinks back and
Okay,
forth,
okay, that's a good sign.
but it didn't.
No. Yeah, now it's Firmata reader. So,
That's unfortunate.
ground, 5 volts. Are we still alive? Yeah. So,
Let's see if this happens to you. No worries, just restart, unplug, replug, and you will be back up. So we wanted to show you how to control this servo motor.
and it's connected to the pin number 9, right?
Yes, apparently.
Okay. So, you see, if I change the value,
Yeah.
it's again so big delay with the camera.
Well, we have direct control here of it's absolute values. That's what
Yeah, that's what
servo
servo
motors
is.
do.
Exactly. You give the angle to the servo, and servo rotates to this angle and stays there until you change the angle.
Okay.
So, controlling motors. Again, vvv patches. I don't know, it's like 3 nodes.
And the
it.
troublemaker is the hardware.
As always.
Okay, shall we show the final example that
Yep.
we brought? We already showed in the beginning, but we wanted to get back to it.
And again, a big notice, because now I want to open the page that we prepared just to make things quicker. But first, we have to disable Firmata device here. Otherwise, it can be only one device connected to port 3, like only one node talking to COM-port 3. So we have to disable. Now, let's close it. Open the
T-port
T-port.
one.
And again,
rewire it.
rewire. So 5 volts, ground, then
4 cables this time.
5.
5.
Now, because you have 5 volts, then you have ground, and then
X, Y, and Z.
X, Y, and Z.
And what's this sensor called?
This is very old one, accelerometer. ADXL 322.
Okay.
It's analog sensor. It's you have to differentiate between analog and digital sensors. Analog sensors give you just voltages on its pins. That means values. And with a digital sensor, you have to talk over a protocol like I2C or SPI. And the digital sensors are much more powerful because you have settings and you need less wires, but it's harder to talk to them. I guess it's a topic for another
A separate episode.
Separate
maybe.
episode.
Okay.
And analog times are super easy because if you see here, we have Firmata device and we read 0, 1, 0, 1 and second, how should I say, 0, 1, 2 analog pins of the board. If we can see the board, then yeah, so you see on the board there's X, Y, and Z pins, and these are connected to 0, 1, and 2 analog pins. Yeah. And if you see the patch again, then
yeah.
So we read these pins, then we create. So you see, there's a list of the values. Then we create a vector from these values.
And since those would be a bit jittery,
this is very jittery, we go through the damper.
The real world is always noisy, so we damp them.
And we create the transformation for the T-port. The rest is just we have a plane, we have some light, and we have a scene window.
Conclusion?
Super easy, quick way to prototype.
Still, like 20 years later, this is still probably the quickest way to get data in and out, for prototyping at least. Maybe you wouldn't run this on a production system like this. Could still do this, but
should we show, because you have to stop me, because otherwise I will plug the pressure sensor and we can control the colors from the pressure sensor.
This we leave to the exercise for the user, or in a separate episode. I think for this episode it's enough.
All right.
We've seen enough. I have nothing to add. I think we went through all the points that we wanted to show. Thank you, Anton. Thank you, operator.
Thank you,
That
Daniel.
was it for this episode. I hope you enjoyed it a bit and tune in the next time. Good evening.